Oh, so cold in Bangalore these days. I can't wait to see the next warmer day. Anyways, let's get back to the question. What? Huh? Look at today's question, guys. Daily temperature, it seems. This is exactly the problem that I've been facing. What a coincidence. Or is it? Huh? Okay, enough of all that. So today's question is daily temperatures. So we are given an array of integers which represent daily temperatures, and we have to return an answer array such that answer of I is the number of days you have to wait for a warmer day. So let me take an example. So this is the new marker. I got it in Amazon office from a friend. Okay, so is it visible? Yeah, fine. So let's take these temperatures like 73, 74, 75, 71, 69. Nice. Okay, 72, 76, and 73. Okay, so let's go from the left. So 73. So if we see, the next warmer day is the next day, so he just has to wait one day, and then for this it is one day more. You have to wait just for one day, that will be warmer. So 75. So the next temperature is lower, 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 later. So you have to wait 1, 2, 3, 4 days. For this you have to wait 2 days. For this 1 day. For this 1 day. For this he's gone. There's nothing he can do. It's never warmer ever, because this is the end of the world. So there's nothing he can do. He's like 0. We'll print 0. That because that is the warmest day and it's gone. And 73, still same thing, gone, 0. So this is the array we have to print. The problem statement seems easy, but how do we do that? Yeah, one way we can do is the way just we did here. So we can go to each let's say we have temperatures A, B, C, and D. We can go to each temperature and keep iterating until we find a bigger temperature. So we have to do that for each and every number, and each number at the worst case will take off n. So it will be like of n square time complexity. So it is slow, because here in the constraints the length of the temperature array can be up to 10 power 5. So n square with 10 power 5 is too slow. So what do we do now? So we have to do optimization. So how do we optimize? If we see one thing, see, there is something that you have to notice. Let me write this big real quick. A, B, C, and D. Anybody can dance. Okay, so we have A, B, C, D. Okay, so first we start with A, and then let's say D is the biggest temperature. No, next bigger temperature. Let's say D is the bigger temperature. So we start from A, we iterate, and we get to D. Fine, cool. But now let's say let's come to C. Okay. So how do you optimize this? Okay. So the thing is, A is less than D. So now B can have, let's take some intermediate number, like let's say X somewhere between B and C. So let's let's see the relationship between A and X. Okay. If X is greater than A, then we wouldn't have to go that far, because if if x was smaller than a, or let's say if x was bigger than a, greater than a, we wouldn't have to go that far because we would have stopped here itself. And let's say if x is smaller than, if a is smaller than x, wait, so if, yeah, so see, let's take two cases. So if a is greater than x, okay, then we have to go forward. But if a is less than x, then we don't have to go that forward. Yeah, it's similar to that. So if you look at that, so when we come to x, okay, so for all the elements, which are smaller than x, if for all elements smaller than x, the answer would be x, like the answer would be the distance from a to x. It will be something like that. So the thing is, we don't have to, like, for each element, okay, let's say we have p1, p2, t1, for all, let's say for all these temperatures, x is the biggest one, okay, so that means all these are in decreasing order. So all these are in decreasing order, so obviously x will be the bigger temperature. So the thing is, we don't have to go till x each and every time if we know that this is in decreasing order. So for every sequence of decreasing order elements, every sequence whose order is decreasing or staying the same, so the answer for all of them would be the end of that sequence. Make sense? So we can do this a lot quicker if we can find out the decreasing sequence of decreasing elements. So our problem would be easy. Like, we'll go from the start, we'll see, okay, is this sequence decreasing, that we can find like O of n, slowly, okay, decreasing. So when it's not decreasing, we go back to the start of the sequence. That, am I making sense? So I'll reiterate it again, okay. So what I am saying is, so we've come to this point that we have if there's a decreasing sequence, like every sequence is a decreasing sequence. You can say like 2, 3. You are saying, okay, this is not a decreasing sequence. No, this is a decreasing sequence of length 1. This is a decreasing sequence of length 2. So every sequence in the multiverse is a decreasing sequence. Okay. So we take a decreasing sequence. So we take every decreasing sequences, and the answer to all these elements in the decreasing sequence will be the end of the decreasing sequence. Fine. So what we'll do, we'll just start from the left. We'll see if the sequence is decreasing. We can just do that by normal comparison. Like, we have 7, we have 2, we have 1. We can say, okay, 7 is greater than 2, 2 is greater than 1. So it's a decreasing sequence. We'll get to know that. So once we get to the end, this is easy. But we know that this is the answer to all these elements. So we have to reiterate. We have to go back to and make all the elements that the answer, tell all the answer, bro, this is the answer. So that we have to do. This is which is like again which is here we are again doing n square because we are doing this loop again. Instead, if we can store these decreasing sequences somewhere, it would be better. So for storing past sequences, we can use a stack. Or you can also use the hint that the last 2 problems in the daily challenge were based on stacks. So you can use stacks here. So we can do that. So we'll take a stack and we'll take the elements. So let's take these elements. So we have 73, 74, 75, 71, 69. Nice. 72, 76, 73. So we take 73, we first put it into the stack. Next we take 74. Now if we see 74, now this is the end of the sequence, end of the decreasing sequence. So we pop 73 like Reddy Anna, and we see the index difference. So let's put mid indexes. So I'll put, so we'll take the index of 1. So the 73 had an index of 0. So I'll say okay. So 73 has to wait for this index will be 1. So for 1 day. So next we'll pop 74, push 74 into inside the array in the stack, and then we'll take 75. We'll see 75. Oh, 75. This is the end of the sequence. So we'll do that again here, and then I'll push 75. Next 71 comes. Okay, 71 is smaller than 75, so it is the part of the decreasing sequence. So I put 71 here, and then I see 769. It is nice, but the part but the point is it is still the part of the decreasing sequence. So I still put here 69, and then 72. Now 72 is big, okay, because it is end of decreasing sequence. So until 72 is the end of decreasing sequence, I'll pop like ready and now. I'll pop 69, I'll note the answer, I'll pop 71, note the answer, and then I'll push 72. The same thing, I'll keep doing that. And this we can do in O of n, and spaces of n, because we are using a stack. So that is the idea behind this. So let's get to code. Welcome back to the code. So let me take a stack from today. Let me use an array as a stack. No, I'll keep using dq, it's fine. From collections import dq. So my stack is this. So for each temperature in temperatures, I'll see. So while there is a decreasing sequence inside the stack, so while stack is not empty and stack dot top is less than temperature, let me have an answer array. Okay, answer is equals to 0 times n is equals to length of temperatures. So okay, so while there is a decreasing sequence inside the stack, I'll pop it off, like ready and now, and I'll put so I know the indexes. Oh no, this, so I'm storing indexes in the stack, so this is just index. So to get the value I have to do temp of, yeah, fine. So index, this is the index. Okay, now so the answer of this index will be, it has to wait for, oh no, I also need index here. Okay, so for end comma temp, enumerate gives you index and values both at the same time. So yeah, so current index minus that index, and we'll keep doing that until there's a decreasing sequence. Once the decreasing sequence is over, it will come out of the loop, and I'll push this back into the stack, the current index, and then at the end, so at the end all the elements remaining in the stack will be the elements who have no future, like no future warm day, just like most of us. Okay, fine. So answer is equals to 0. So for them we have to put answer equal to 0, but the thing is by default it is 0, so who cares, let them be 0. And then we have to, at the end we have to return the answer. Let's go. Okay, what's the problem? Object is not subscriptable enter. S is a DQ, so int is not subscriptable. Oh, sorry, temp is this value, temperatures is what we want. Yes, yay. Yeah, so that's it guys, hope you all have warm days ahead of you, and I hope it is near. Yeah, that's it guys. If you like the video, like it, and if you didn't like it, then send it to your enemies so that they waste their time too. Haha. Bye bye.